getting affected. Okay, its diameter is not here. Sorry, my mistake. Wherever the quill is there, the diameter has not increased. But wherever in between the quills, the diameter increases. So you have a wave. You have this kind of pattern of the wear. The wear is not even. The wear is not circular. The wear is of this pattern. This pattern is called as clover leaf pattern. Why it is called as a clover leaf pattern? Because there is a clover leaf which it resembles a clover leaf, and that's why it is called as a clover leaf pattern. These are the positions of the quills. ये quill position है, ये quill position है, ये quill position है आपका, ये quill position है आपका. Okay, this is the quill position, and last this is the quill position over here. So quill position पे आपका wear कम होगा, in between the wear will be more, and the liner diameter would have increased. This is known as clover leafing, and this happens because of the phenomena which I had explained to you. Now let us see what is clover leaf. This is a clover leaf. There are three petal clover leaves. There are 4 petal clover leaves. The most common one is 3 petal clover leaf known as trifolium or trefoil. It's a genus of about 300 species of plants which are there. It's a leguminous pea family. You don't have to worry about what family it is. The word has been picked up from the shape of this leaf. Because you will find कि यहाँ पे इसका diameter कम है, फिर इसका diameter बढ़ गया. Again it has reduced, again it has increased, reduced, increased. So you can assume कि ये quill position है जहाँ आपका diameter less है, ये quill position है. In between clover leafing is happening. That in between the corrosive wear is more. That is, if you assume, then this is how the liner diameter varies over a period of time. It will happen after tens of thousands of running hours. Is that understood?
Yes, sir. Yes, sir.
So clover leafing, when it is coming, please try to explain with the help of diagram. Please don't just make it like that. Please try to use the diagram, and both the diagrams should be there. There should be a top view which should be used. There should be a side view which should be used. And the way I made the bands and all and explained to you, please make that. Here also, this left side figure also, you can see some bands are shown. But if these bands are not shown with respect to the quill position, then it becomes difficult. If the bands are shown with respect to the quill position, and with the respect to this wave cut patterns and all, it becomes very easy to understand. और उसको correlate करो इसके साथ में. Try to correlate it with the top view, cross-sectional view, top view. And here you should have a side view. Both the views must be made to explain the clover leafing. Please do not explain only in words. Always make use of figure. But figure में अगर आपने ये गलती कर दी कि आपने quill को यहाँ बना दिया, और ये बोल दिया कि quill की middle position है, तो you have gone 100% wrong. Your logic has gone 100% wrong, and you'll get 0 marks for the same. Because जहाँ पे आपका liner का wear diameter is less, means wear is less, वो quill का position है. In between the two quill position, your liner diameter has increased. So this is what you need to keep it in mind very clearly.
Yes, sir.
Okay. Now let's talk about the liner wear rate and liner wear limits. This is a very commonly asked question, especially when you go for your MEO class 4 exams, or when there is a question on liner wear. This one of these questions, or both the questions, can be asked along with the wear of the liner.
Excuse me, sir.
So whenever, yes,
sir. How we can reduce the clover leafing, sir? Is there any method?
Clover leafing is reduced. Yes, that's a very good question. So let me share my whiteboard and then write down over there so that you can note down those points. So clover leafing can be reduced. 1, increasing cylinder lube oil feed rate. So when you're increasing the cylinder lube oil flow rate, the oil which is able to reach the bottom of these grooves, that will be still having sufficient alkalinity, correct? That is one thing. Second thing is increasing BN value of the oil. So when you have increased the BN value, so say earlier you were using a 50 BN value, वो यहाँ पहुंचते पहुंचते 30 हो रहा था, तो now you increase it to 70. So here it is reaching 50 or 60, it is reaching, and that is good enough to utilize the assets and all. So I'm just taking all the arbitrary figures and all. So this is another way you can increase that. Then one more thing which you need to see is कि ये जो आपका wave cut pattern है cylinder liner में, जो wave cut pattern है, is two more things which you need to see actually. Is the lube oil flowing out from the lube oil quill without obstruction? What happens sometimes, the cylinder liner gets worn out and this quill, the hole through which the oil drains out, pours out, it gets partially covered. Okay, so and also the wave cut groove which is there, it gets partially filled up because of the wear is taking place, and this groove does not remain of sufficient depth. It is not of sufficient depth. So iska depth khatam ho gaya groove ka, that it is not able to retain sufficient quantity of oil. When it is not able to retain sufficient quantity of oil, most of the oil which is getting poured out of the quill, it tends to fall out nearby the quill only. Less amount of oil is reaching the end of the grooves. So because the depth of the groove has reduced. So this is also another thing which must be noticed. Okay, see, groove has not worn out and the groove depth has not decreased. So these are some of the points which will help you in reducing the global leafing. Okay. Then coming to the cylinder liner wear rate. Cylinder liner wear rate, हम wear की बात नहीं कर रहे हैं, पहले हम wear rate की बात कर रहे हैं. Wear rate is calculated per 1000 hours usually. कितना मिलीमीटर wear हो गया लाइनर में per 1000 hours? मिलीमीटर per 1000 hours. Cylinder liner wear rate is expressed in millimeter per 1000 hours. Okay, the rate of wear will vary over the life of the liner. There is something called as a bathtub curve, which most of the machineries they follow. That is sometimes called as bathtub curve. You'll find that initially, if I say the life is like this and the wear rate like this, if I plot it over there, this is a very common terminology in the industry. This is called as a bathtub curve. It follows this bathtub curve. So initially, whenever we put any new machinery into service, its wear rate is very high. It has got a very high wear rate, as you can see. Initial service period. So I can start it from zero also. From here also I can start. And I can continue like this. So uska wear rate bahut zyada hota hai. Then as the wear in takes place, we call it as wear in or running in. You must have heard of running in, bedding in, running in, wear in. All these terms are used. Then the wear rate starts to decrease. And after a few hundred running hours, the wear rate will fall down to minimum and it will remain constant for the entire life of the cylinder liner, of that machinery, of that piston ring, of bearing, of whatever. It will remain constant for the entire life. But when the liner is reaching almost its end of its useful life, not exact end of useful life, it may still run for 10,000 more or 5,000 more running hours, then you'll find that the wear rate again starts to increase. And when it has reached the extreme end of its life, the wear rate becomes catastrophic. It becomes extremely large. So this is the one, if you try to plot the wear rate onto a graph, then you will come to know whether the liner is operating in this normal range of its normal life, or it has exceeded its normal life and it is operating in this range. That also you can come to know. So this is for your information. You must remember this bathtub curve which is there, which tells you for not only for the cylinder liner only, but for other equipments as well. This is true, generally considered to be true. It is high at running in, it is constant during the useful life, and it is excessive when the liner becomes excessively worn out. Approximate normal wear rate is considered to be 0.1 mm per 1000 hours. For large marine two-stroke crosset type of marine diesel engines, the acceptable wear rate, normal wear rate, is considered to be 0.1 mm of the liner diameter, 0.1 mm of the liner diameter. तो अगर आपका 1000 hours के बाद में liner diameter instead of liner diameter which is 900 mm, 0.9 meter bore का diameter है, if it has become 900 mm, from that it has become 900.1 mm after 1000 running hours. It is absolutely normal. Initially you will find that it will be more, but after the bedding in or running in takes place, you will find the initial wear rates maybe 900. After 1000 running hours it may become 900.5, then another 1000 it may become 900.067, then 900 it will remain constant with 0.1, 900.2, 900.3, like that. It will continue for several thousand running hours, or 50,000 for 1 lakh running hours. It will continue like that. Yes, the life of the liner, useful life of the liner may be around 50,000 to 1 lakh running hours for huge these marine diesel engines. So at the end, you will find that the wear rate increases. It increases considerably. Where is the useful life end? Where does it end? That is decided by the wear limits. So cylinder liner wear limits, maximum wear before renewal is 0.6 to 0.8% of the liner diameter. So if the liner diameter was 900 mm bore, multiply it by 0.6. What is that? What is that? How many mm?
5 foot. 5 foot.
0.6. 0.6% है, ठीक है? It's 0.6%. So 0.6 by 100. So multiply it. So 540 by 100. How much it is? 5.4 mm. So अगर आपका 900 mm diameter liner is there, if it reaches 905.4 mm, you are approaching its end of its useful life. And if I do this, it comes to 7.2 mm. If your liner has reached 907.2 mm, exact will depend on what the maker has told you. Okay, 7.2 नहीं है, अच्छा 960 को मैंने लेके चला है एग्जांपल इधर, तो इसीलिए वो 7.7 आ रहा है. मैं यहाँ 900 को लेके चल रहा हूँ, तो इट इज कमिंग टू 7.2. तो 900 mm का जो डायमीटर है, इफ इट हैज रीच्ड 907.2, दैट मींस यू हैव टू डिस्कार्ड द लाइनर. यू कांट यूज द लाइनर एनीमोर. दिस इज द एंड ऑफ यूजफुल लाइफ. द एक्सट्रीम लिमिट you have already reached. So can you tell me that if you are doing the liner calibration every 15,000 running hours, if you are doing the liner calibration every 15,000 hours, liner calibration मालूम है सबको? Measurement of the liner diameter known as liner calibration.
Yes, sir.
उसको liner calibration बोलते हैं, ठीक है? So if you are doing liner calibration every 15,000 running hours, मतलब कि इंजन आपका 50,000 घंटे चल गया है, आपने लाइनर कैलिब्रेशन कर लिया, ठीक है? नेक्स्ट आप कब करेंगे? 65,000 रनिंग आवर्स पे करेंगे. और ये इसको मैं 45 ले लेता हूँ, इसको मैं 45,000 रनिंग आवर्स ले लेता हूँ, जिससे कि ये 15 का मल्टीपल हो जाएगा. नेक्स्ट आपको 60,000 पे करना है. तो अभी मेरा क्वेश्चन ये है कि अगर 45,000 रनिंग आवर्स पे आपका जो लाइनर का जो डायमीटर था, वो आपने पाया, whatever you found was 906.9 mm. Should you use this, continue to use this liner, or discard this liner? I will repeat my question. And for everybody, please pay utmost attention before you start doing anything. At some port, you reached, and one of the particular liners, say number 1 unit of your engine on board ship, you did the liner calibration, and at that time the number of running hours of your engine was 45,000, and you found that your liner diameter of 900 mm bore diameter engine, the liner diameter upon calibration, the average diameter was found to be 906.9 mm. Though it is not average, it's the maximum which is considered. So it is 906.9 mm. The maximum diameter of the liner which you found was 906.9 mm. Now, you know that the next liner calibration will only be done. You are going to open up the unit and doing the next liner calibration only at 60,000 running hours. After good 15,000 running hours. Can you continue to use this liner because it has not yet reached this limit? Can you continue to use this liner for next 15,000 running hours? Yes or no?
No, sir.
No.
Why no? And if somebody is saying yes, why yes?
Sir,
Yes.
after 15,000 hour, if we take the average as average rate as 0.1 mm per thousand,
Yes.
then it will be 1.5 mm.
Okay.
And
0.1 mm. Yes, let me write down 0.1 mm plus per 1,000 hour multiplied by 15,000 hours, right?
yes,
And
sir.
that is coming to 1,000. आपका ये per 1,000 hours से तो 1,000 यहाँ से cancel हो गया and it is coming to 1.5 mm. 1.5 mm added to 906.9. 1.5. How much we are coming to? We are coming to 908.4 and we are far exceeding our limit of highest limit of 907.2 mm. Very good, Anirudh. Excellent. So it's very good. So you have, I think everybody has understood what I mean to say.
Sir.
Yes, sir.
Yes, sir.
Excuse
समझ
me,
में
sir.
आया? इसीलिए जब आप जहाज पे होंगे when you are there on board, please apply these logics. मैं आपको practical समझा रहा हूँ. देखो, I am teaching you in a theory class. I am teaching you the practical effect, and many times the engineers make this mistake. वो क्या करते हैं? उन्होंने measure किया अभी, and without thinking कि मुझे 20 घंटे के बाद लाइनर का calibration करना है. I'm not going to open up the unit in next 10,000 hours for changing the piston. Forget about the liner calibration. And my this thing is reached and engineer decides nahi abhi to wo limit mein will continue, and it's a fatal decision. Let me tell you, because if you continue to use a badly worn out liner, it may crack, it may give you blow past, it may cause the collapse of the piston rings, it may cause many more problems. Yes, what was the question? Please go ahead.
Sir, after this, can we use 3,000 more hour of running? Because we are having 0.3 mm more.
Yes, we can do that, but the problem, there are two problems. The problem number one is what Anirudh calculated with, and I did calculation, was a normal wear rate, right? Please understand, when the liner has already 900 mm bore diameter, liner has already got worn out up to 906.8 mm. Its wear rate is no more 0.1 mm per 1,000 hours. Its wear rate will be somewhere around 0.5 mm per 1,000 hours. And this liner may not be able to last even 1,500 hours, even 1,000 running hours. You understand that?
Yes, sir.
It will be 3-4 times minimum, and it can go up to 10 times, 8-10 times. You don't know. It becomes unpredictable at that point of time when it is near the end of its useful life. That is point number one. Point number two. Every time opening up the unit involves heavy cost to the owner. Heavy cost in terms of manpower involved, in terms of downtime involved. If you want to replace the liner, it may take 20-24 hours for an engine. It involves some spare parts consumption. And that may be at a cost of maintenance of something else, because you have to do it in port. So it's a heavy cost involved. So you will never be running a cylinder liner for 2,000-3,000 running hours. So this is a practical aspect which I am telling you. Minimum, yes, if it can last for 10,000, probably, and if the company so decides कि नहीं, we are sure कि 10,000 running hours तो ये चलेगा ही, तब हम use कर सकते हैं. But nobody will take that risk for 10,000 running hours, because the losses which you will incur because of the damage of this liner and your ship getting stuck out at sea, and probably you are calling a tug assistance, a salvage tug assistance, and maybe in the middle of the sea under bad weather condition, and where the ship may itself and the lives may be lost. This kind of chance will never be taken. So that's why this chance will never be taken. So first 2 points also which I told you, these are also important, but the third one is safety, and that is also very important. So actually क्या है, 6 to 8%, इसीलिए आपको 0.6 to 0.8% दिया गया है. 0.6 to 0.8% दिया क्यों गया है कि जब आपने when you open up the liner for inspection, if the wear is greater than equal to 0.6% of D, you must discard the liner. This is a very, I'll say, intelligent decision to do that. But if you say कि नहीं 0.8 तक का लिमिट है और तब तक हम जा सकते हैं, then probably you are going in some arena where you are creating a doubt as to the safety of the ship, safety of the engine, and so on. And remember, ये जो 0.6 to 0.8 है, am I audible to all?
Yes.
Yes,
Yes,
sir.
ये जो 0.6 to 0.8 है ना, ये बहुत ही जेनरिक है. एग्जैक्ट क्या है आप अपने इंजन मेकर का मैनुअल में देखिए, एंड यू विल कम टू नो व्हाट इज द एग्जैक्ट वैल्यू योर इंजन मेकर हैज गिवन यू. And please don't exceed that, and please do the calculation. But as an engineer, as a learned engineer, and not like a fitter, you should keep these values at the back of your mind always when you are there on board. ये पहला वैल्यू, बट ये याद रखो ये नॉर्मल वेयर रेट है, और इसके साथ में आपको ये भी याद रखना है कि देयर इज समथिंग कॉल्ड एज बाथ टब कर्व, जहां पे आपको वेयर रेट यहाँ पे होता है और आपकी लाइफ यहाँ पे होती है, रनिंग आवर्स यहाँ पे होते हैं. तो यहां तक तो ये 0.1 चल रहा है, ये 0.1 है, बट यहाँ पे क्या हो गया, 0.2 हो गया, यहाँ पे 0.3 हो गया, यहाँ पे 0.4 हो गया. तो आपका वेयर रेट ड्रास्टिकली इंक्रीज करने लग गया जैसे ही वो 0.6% ऑफ डायमीटर को क्रॉस कर गया. बट ये जो 0.6 है, ये तो एक जेनरिक अप्रोच है. एक्चुअल आपके मैन्युफैक्चरर मेकर ने क्या बोला है, प्लीज ट्राई टू स्टिक टू दैट. इज दैट वेरी क्लियर टू एवरीबडी?
Yes, sir.
Yes.
Okay, so I hope that you have noted down some of these things also, because these have got a lot of practical significance. ये खाली थ्योरी नहीं है, ये थ्योरी को अप्लाई करना है. ये देखिए, ये बात टब कर्व की बात में कर रहा था, लाइनर वेयर रेट वर्सेस टाइम कर्व. ठीक है, तो यहाँ पे आपका रनिंग इन हो रहा है शुरू में, then you have the steady wear rate for very very long time. तो ये आपका छोटा पीरियड है. एक्चुअली ये बहुत बड़ा पीरियड नहीं होता है. ओके, एंड देन उसके बाद में आप देखेंगे कि यू विल फाइंड इट इज वेरी स्टीप. ये इतना स्टीप नहीं होता, दिस इज नॉट सो स्टीप, बट दिस इज वेरी स्टीप. तो ये आपका अगर 0.1 था यहाँ पे, ये 0.2 हो गया, 0.3 हो गया, 0.4 हो गया, लाइक दैट इट कंटिन्यूस एंड इट गोस अप ड्रास्टिकली. और ये तो वेयर रेट था. और ये एक्चुअल वेयर को अगर मैं प्लॉट करूं विद टाइम, actual wear means liner diameter, actual diameter minus original diameter, इसको बोलते हैं wear is equal to the actual wear. तो जो actual wear को अगर हम प्लॉट करेंगे तो initially the wear will be high, फिर the wear will become lesser with time, not very steep, but at the end the curve will become very steep. The curve will become very steep. Okay, ये देखिए बहुत कम टाइम में, तो it is, ये क्या दर्शा रहा है, this is showing the same thing that your wear rate has increased over here, because in a very short period of time the wear has increased considerably. कितना wear बढ़ा, ये 3 points wear बढ़ गया, और टाइम कितना लगा, खाली 2 points का टाइम लगा यहाँ से यहाँ तक. जबकि यहाँ पे कितना था, wear rate आपका कितना बढ़ा, टोटल 2 point बढ़ा खाली. over which, how many points of time, 1 2 3 4 5 6 7 8 9. So this itself is an indication. If you keep plotting it on board, you will come to know कि कब आप इस एरिया में आ गए, कब आप इस एरिया में आ गए, कब आपने इस स्टेडी स्टेट वेयर को छोड़ दिया है. And if you test it, if you check it, you know, after whatever consecutive liner calibrations, you can get an early indication of the liner failure, and you can take a corrective action. Please remember that. Is this clear?
Yes, sir.
Yes, sir.
हाँ, तो ये आपका ट्रबल शूटिंग है फोरकास्टिंग के लिए कि अभी लाइनर का हाउ मच इफेक्टिव लाइफ इज रिमेनिंग, क्या हमें लाइनर अभी रिप्लेस करना चाहिए, नहीं करना चाहिए, तो क्या डू वी हैव अ स्पेयर लाइनर, सपोज वी हैव स्पेयर लाइनर बिकॉज दिस आई मे बी एक्सपेक्टिंग कि इन अनदर ईयर माय लाइनर इज ड्यू फॉर रिप्लेसमेंट, so what I have one spare liner, what I'll do, I'll raise a requisition, I'll raise an indent for another new liner to be purchased and procured and supplied to the ship in another 1 year. And once I get that another new liner, I'll immediately in the next opportunity in the next port, I'll replace this liner. So this is how the things work, and that's why you need to see the trends, you need to see the graph, and you need to record maintenance is very important on board, and you need to be actually sometimes plotting the things and trying to come to some conclusion. Okay.
Excuse me, sir.
Yes.
Sir, do you have to replace all the liner at a time? Because running hour is the same for all.
No, you don't have to replace all the liners at the same point of time. The reason is that first of all, yes, when you take the ship new, when you take the delivery of the ship new, so all of them are in the same condition. But over a period of time, I'll tell you what happens. Over a period of time, there is a staggering in the plant maintenance system. Staggering word जो है एक बहुत बड़ा word है और बहुत commonly use होगा. Staggering. The schedule staggering is done. Schedule staggering is done. So अभी आपको मान लीजिए 15,000 hours में यूनिट को खोलना है, तो आप यूनिट नंबर 1 को क्या करेंगे, शुरू करेंगे. Maybe you can start. एक मिनट. So unit number one, you'll start opening say at 12,000 running hours. Unit number 2, आप देखेंगे कि हाँ 14,000 पे करना है, 13,000 पे करना है, like this. And some of them you may exceed also because you can't open all the units at 15,000 running hours. But ये ऐसे ही यूनिट को ओपन करके नहीं देखा जाता है. उसको ओपन करने से पहले स्कैवेंज इंस्पेक्शन किया जाता है. Scavenge inspection is a very powerful tool. This tells you when you open up the unit at 15,000 running hours. Yes?
Sir, in between your voice was not coming. After you said that before opening we have to do scavenge inspection.
Okay. So scavenge inspection, is my voice coming clear now?
Yes, sir.
Just a minute. Again, it is showing unstable connection. So scavenge inspection is a very powerful tool. That's what I am saying. Scavenge inspection is a very powerful tool. And it is not that ki agar 15,000 running hours is written in the plant maintenance system, then we must open up the unit at 15,000 hours. If the chief engineer can justify that based on the scavenge inspection, we found that the unit was performing well. He has the photographic, videographic, and the measurement and based evidence and all he has recorded. Then he can always defer this 15,000 to 16,000 and 17,000 also. Okay, he can defer that. So he can defer this inspection routine, not inspection, maintenance or opening up of the unit. He can do that. So the final effect, what you will find is unit number 1, it opens at 12,000 running hours. Unit number 2 at 13,000 running hours. Unit number 3 at 14,000 running hours you are doing. Unit number 4. Like this, you have staggered the schedule, and up till 20,000 running hours, you continue to open up the units, and even more. Because you have done this, every time you are doing the scavenge inspection, if you find that particular unit requires more attention, you can open that unit up first and try to do that. So once these units, they get staggered, you know that now 12,000 plus 15,000 hours will be added, and next time you have to open up this unit at 27,000 running hours, and the last unit which was opened up at 20,000 plus 15,000, it needs to be opened up at 35,000 running hours. And I have just given you a very arbitrary example. So इसके लिए जब होता है तो कुछ staggering किया जाता है, maintenance schedule को stagger किया जाता है, तो all the things will not fall due at the same point of time. That is point number 1. Point number 2, all the units, they never behave the same way. Like all fingers in your hand, they don't behave the same way. They are not of the same size. They don't work the same way. So like this, all units, in spite of them being identical in the beginning, and the maker has given them, designed them identically, they do not continue to operate the same way for the entire life. Somewhere the combustion is better, somewhere it is slightly less better, somewhere it is poor. And like this, the condition continues to get altered, and so is the wear condition, and other conditions also inside the cylinder continues to get be different. Is that clear?
Yes, sir.
So I hope that you got the answer, right?
Yes, sir.
Okay. So can you see my cylinder liner wear pattern on the slide?
Yes, sir.
Yes, sir.
Okay. So now what is the wear pattern? This is also very important, because क्या होता है कि when we are measuring wear, if you are measuring the wear at the wrong position, we may not be able to capture the maximum wear. तो सबसे ज्यादा क्या होता है, ये है न्यू लाइनर. ये क्या दिखाया गया, साइड व्यू. लाइनर का अगर हम साइड व्यू देखेंगे तो लाइनर हमको सो लाइनर हमको दिखेगा, आई विल बी एबल टू फाइंड द लाइनर समथिंग लाइक दिस. इसका क्रॉस सेक्शन अगर मैं लॉन्गिट्यूडनल सेक्शन अगर मैं देखूंगा तो लाइनर का 1/3 व्यू है, और अगर मैं इसी को कॉपी करके और मिरर कर दूं तो दूसरे साइड में भी मुझे ऐसा दिखेगा. I'll be able to see on the other side also. Right? So 1/2 इसका दिखाया गया है राइट हैंड साइड में. ये राइट साइड का नहीं दिखाया है, लेफ्ट साइड का खाली 1/2 दिखाया हुआ है. What you see on the right hand side, ये आपको 1/2 of the new liner is shown. तो न्यू लाइनर में लाइनर का पूरा सरफेस इवन है, कोई वेयर आउट नहीं हुआ है. But as the liner continues to wear out, in the topmost region, the wear is maximum. Why it is maximum? Because of two main reasons. One, extremely high. There are not two main reasons. One is frictional wear is high, extremely high friction wear. Frictional wear is high. And the second is high corrosive wear. Corrosive wear is high. ये टू मेन रीजंस हैं जिसकी वजह से यहाँ पे आपका वेयर रेट इज वेरी हाई, द वेयर इज वेरी हाई. At the end travel of the topmost piston ring, you'll have this wear increasing, and very close to the end travel, the wear will be maximum. यहाँ पे इस region में wear बहुत ज्यादा है, and your wear then continues to decrease as you go down, and again in the scavenge port region, the wear increases. So when you continue to use the liner after several thousand running hours, you'll find कि इसका diameter यहाँ पे liner का maximum यहाँ पे हो जाएगा, और यहाँ पे भी increase हो जाएगा scavenge port region में. Why scavenge port region it will increase? Because of the scavenging. As the scavenger blows in, it washes away the cylinder lube oil film. And when it washes away the cylinder lube oil film, the friction will increase between the piston ring and cylinder liner. Is that clear? तो इसीलिए यहाँ भी wear increase होता है. Here the wear does not increase because of the high temperature, because there is no high temperature. Here the wear increases because of the high combustion load, high load, and high temperature, and high acidic content. तीन चीजों की वजह से यहाँ पे आपका wear increase हो जाता है टॉप में. So this is the wear pattern which you are going to get close to the TDC. Plus the hydrodynamic effect of lubrication is less. The load is very high, so oil film thickness has become very less, and that is why the wear increases. The metal to metal wear increases. So these are some of the reasons which are mentioned over here. Is that clear? Any doubt on the same? No?
No, sir.
No, sir.
Okay. Then there is a cylinder liner gauging which is done. Okay. Cylinder liner gauging में क्या करते हैं? ये एक फॉर्मेट है पोजीशन का, जहां पे आप सिलेंडर लाइनर का नंबर लिखते हैं, 1 2 3 4 5 6 कौन सा नंबर है वो लाइनर का, डेट डालते हैं, आज का डेट हम डाल सकते हैं इसमें. वी कैन पुट से नंबर 2/06/2021. Date fitted, let us say it was fitted in say 2010. कोई डेट को उसको फिट किया गया था, जून 2010 it was fitted there. Last date of last gauging, let us say date कब गेज किया गया था, आज से 2 साल पहले इसका गेजिंग किया गया था, let's say 2018 में गेज किया गया था जनवरी में. टोटल रनिंग आवर्स कितने हो गए इसके, let us say it has run 56,000 running hours till now, and hours since last gauging, let's say it has run 12,000 hours since last gauging. तो इस तरीके से हमें पोर्ट एंड स्टारबोर्ड डायरेक्शन में एक तो हम मेजरमेंट करेंगे, ये फॉरवर्ड है, ये आफ्ट है, ये पोर्ट है और ये स्टारबोर्ड है. ठीक है, तो पहले तो हम पोर्ट और स्टारबोर्ड. डू यू हैव अ नेक्स्ट क्लास?
Yes.
sir.
ओके, सो पोर्ट स्टारबोर्ड डायरेक्शन में हम गेजिंग करेंगे. Screw micrometer is used. Very simple. You have used screw micrometer. Yes or no? That micrometer.
Yes, sir.
Yes, sir.
तो इंटरनल माइक्रोमीटर हम यूज करेंगे और उसको पहले हम पोर्ट स्टारबोर्ड डायरेक्शन में लेंगे, फिर फॉरवर्ड आफ्ट में लेंगे, और यहाँ जो भी मेजरमेंट आएगा 900.06, 900.08, बी पॉइंट पे ज्यादा आएगा तो 901.3, 901.4, कुछ आता रहेगा, वो सब हम नोट करते रहेंगे. फिर हम देखेंगे मैक्सिमम वेयर कितना है. वेयर कितना होगा, वेयर विल बी द एक्चुअल कैलकुलेटेड डायमीटर माइनस ओरिजिनल डायमीटर. तो मैक्सिमम वेयर लेट अस से हमको आता है 0.3, यहाँ पे आता, सॉरी नॉट 0.3, 1.3, यहाँ पे आता 1.4. फिर ओवलिटी कितना है, ओवलिटी मैक्सिमम माइनस मिनिमम, ये हमको ओवलिटी देता है, वो कैलकुलेट करेंगे. मीन मैक्सिमम वेयर कितना है वो हम कैलकुलेट करेंगे. ठीक है ना. वेयर रेट सिंस लास्ट गेजिंग हम कैलकुलेट करेंगे, उसको नंबर ऑफ रनिंग आवर्स से डिवाइड करके, और यहाँ जो भी रिमार्क्स डालना है वो हम डालेंगे. इस तरीके का हम रिकॉर्ड मेंटेन करेंगे. विल बी मेंटेनिंग दिस रिकॉर्ड, विल बी मेजरिंग इट. एंड मेजरमेंट के लिए द मेजरमेंट्स आर डन एट A, B, C, D, E, F, G, H, like that, so many number of points. And these points are decided on the basis of a template. We'll continue in our next class, a template hai. So please let me know where we stopped here in this class. Please let me know. Okay?
Yes, sir.
Yes, sir.
Okay, fine. Thank you very much. And please read about it. It's an interesting thing. You can go visit the net also and try to see some photographs and all and how it is done, because everything is not possible to be covered in the class. Please do that. Okay.